think you were supposed to do the even numbers. And this is pretty simple, but it goes back to you reinforcing that the properties we're talking about, right? Um, so it's understanding that if you add to both sides of an inequality or subtract, it doesn't change the result. Yeah, the inequality, the order of the inequality, it's still gonna remain the same. So let me just go back and see if I can write this here. So let's say inequality, I don't know, 100 is greater than 20. Now let's say I add 5 to each side. Right, I get 105 over here, and I get 25. So the inequality here, right, stays true when I add. Now, even if I subtracted 5 from each side, so let me just erase this. Right, so let's say I subtract, I don't know, let me make it 15. Subtracted 15 from each side. This is 85. Does the inequality stay true? Yeah, it still stays true. So that doesn't change. So whether you add or subtract, the same value, of course, to both sides, the inequality, the order of the inequality, it's not going to be affected. Okay. Now, with multiplication is a little bit different. So I mean, let me pick a different number. 20 is less than 50. So let's say I multiply both sides times 5 and then times 5. 5 times 20, this would become 100. 50 times 5, this would become 250. Notice that the inequality still stays true, right? 100 is still less than 250. But there's no issue there. Now, there's an issue when you multiply it by a negative number. So let me pick an easier number. Let's multiply both sides by negative 2. And let me multiply the right side by negative 2. So negative 2 times 20 gives me negative 40. Less than, and 50 times negative 2 gives me negative 100. So notice now, let me put these two numbers on number line. Here is 0, here is negative 40, and this here is negative 100. So remember, right, the further left you go, the less value you have. So this says that negative 40 is less than negative 100, which is obviously not true. Negative 40, if you look at the number line, is to the right of negative 100, so it definitely it's more value, right? Because it's further to the right on the number line. So any number that's to the right, of the other number you're comparing to is the greater number. So in order to keep this inequality true, because we multiply by a negative number, right? So the order of inequality has to be reversed. So what I mean by that is that this, well, right? So in order to keep that true, because we multiply by a negative number, we have to reverse the inequality sign that way to keep it a true statement. So that's what we talked about today. Okay. So when you multiply, or even when you divide, and I'll do one more. Right. So let's divide by let's divide by negative 10. So let's say I divide both sides by negative 10. If I divide 20 divided by negative 10, it's going to give me negative 2. 50 divided by negative 10 is going to give me negative 5. So again, let me put these two numbers on number line. Here's 0, here's negative 2, and here's negative 5. Now, who's further to the right? Negative 2 is further to the right, which means negative 2 has the greater value. So this is not a true statement. So when you divided both sides by negative 2, the inequality, the order of the inequality, it is not, didn't stay the same. So in order to make the adjustment, you have to reverse the inequality sign. Okay, and that's what these problems talk about. So we're doing the even number. So number 2. So here's your inequality. Negative 6 is greater than 2. Sorry, less than 2. And you're adding negative 4 to each side. So let's do that. So plus negative 4 on this side, plus negative 4 on this side. Let's say, so we're adding, put a plus. So we're adding negative 4 to both sides. Negative 6 plus negative 4 is negative 10. 2 plus negative 4 is negative 2. Does the inequality stay still true, remain the same? Yeah, because negative 2 is less than negative 2. So negative 10 is less than negative 2. So the number 2, the sign, it says, what sign do we put here? Well, we're going to put a sign here. It's less. So adding negative 4 to both sides is not going to change the original inequality that we have. So that keeps it simple. So again, when adding or subtracting a value, the same value from both sides of an inequality, the order of the inequality will remain the same. Only when you multiply by a negative or divide by a negative number, that has to be reversed. So 4, negative 2, so the original one is negative 2 is greater than negative 8, and what are they doing here? They're subtracting negative 1/4. So I don't care what you're subtracting. So They're subtracting 1/4 from this side, subtracting 1/4 from this side. So the answer, whatever that answer ends up being, the inequality sign is still going to go that way. So this becomes, if you think about it, becomes negative 2.25, and this becomes negative 8.25. As you can see, negative 2.25 is greater than negative 8.25. So there's not much. You didn't have to do the calculations. All you got to really pay attention is, are we multiplying by, are we adding, are we subtracting, are we dividing, or multiplying? So that's what. So in the number 6, the original equality is negative 4 is less than 1, which is true. And then what is he doing here? He's multiplying both sides. So if you multiply this by negative 2, multiplying this by negative 2, well, whatever the result is, right? Let's actually do it. Negative 4 times negative 2 is 8. 1 times negative 2 is negative 2. So if you keep it like this, right, the inequality sign, the original one, as that, it's not going to be, because it's not going to be true, because 8 is not less than negative 2. So to make up for the fact that we multiplied both sides by a negative sign, we have to reverse the inequality sign that way to keep it true. Okay, so the answer to whatever that was, that quiz that we're doing, number 6, the sign has to be reversed. Number 8 is 9 is greater than 6, and they're dividing. They're taking that 9 and dividing by negative 1/3, and dividing the 6 and dividing by negative 1/3. So again, we know that, and again, I don't really care what the result is as far as the division, but what I know is that whatever result, whatever number I have here, whatever number I have here, it's not going to matter. I need to reverse, because this number over here is going to be the greater one than that number. Okay, and oops, the sign has to be reversed. So anytime you multiply or divide by a negative number, you have to reverse the sign. So that's basically what we're doing. 10, y is less than 6. So if you subtract 2 from this side and subtract 2 from this side, guess what? Doesn't matter what the answer is, that sign is still going to be a less than sign. Okay, we don't need to reverse it. Okay, and that's what you have to think about. 12, so 12 says, here's a number, it's less than 64, and if you divide this side by 8 and you divide this side by 8, whatever the result here, right, whatever result here was the result here, does the inequality, do we keep the inequality sign as the original one, or do we reverse it? Well, we're dividing by a positive number, and we're dividing both sides by a positive number. So whatever resulting numbers we have on the left side and the right side, it doesn't matter. This side will be less, this number will be less than that number. There's nothing we can do. So the sign that we want is this, less than sign. 14, y is less than 8. So now here they say, let's divide the left side by negative 4, and let's divide the right side by negative 4. Oops. Right? So all we need to know is that whatever result we get, because we divided the both sides by a negative number, whatever answer we get, we have to adjust. Right? We have to adjust the inequality sign, reverse it, so because to keep the inequality true, the sign has to be reversed. Okay? So the answer to number, whatever this was, is greater than. 14, 16. So if you have this, y minus 3 less than 12, and they're saying let's add 3. Here's let's add 3, and let's add 3 to the other side, right? So what? Well, let's just do this. So 12 plus 3 on the right side, 15. And then here, negative 3 plus 3 is just 0, right? It goes away. So because we added 3 to both sides, right? When we add or subtract the same number to both sides, the order of the inequality is not going to change. So that's still going to be a less than sign. Okay. 18. 18. So what happens when I take 2x? The inequality 2x is greater than 8. And as you can tell, you're saying, let's divide this side by 2, and let's divide this by 2. Well, if I divide the left side by 2, this and this becomes 1, so I'm left with x. And 8 divided by 2 becomes 4. So because we divided by a positive number, our inequality, the order of inequality stays the same, and the symbol we're looking for is greater. So nothing changes. 20, you got negative 3x less than 36, and they're saying let's divide this by negative 3 and let's divide this by negative 3. So right away, because we're dividing by a negative number on both sides, we know that the inequality has to be reversed in order to keep the order inequality true. Okay, so this actually is going to become x, and this is actually going to become negative 12. So we actually have to, this has to be reversed. Now that's pretty much what you have to keep in mind. Okay, up to, I don't know, 22, x is less than 5. And if x is less than 5 and 5 is less than y, what is the relationship between x and y? So let's graph this. So okay, let me graph this on this side. So if x is less than 5, we're talking about these numbers. Any number, right? So these are the x values. On this side, it says y less than y, 5 less than y. Right, so like put a circle, again, not shaded, so 5 is not part of the solution. We're talking about these numbers, right? 5 is less than all these numbers. And which are these numbers that 5 is less than? Well, it's these numbers, the numbers to the right of y. So that is, so x are all the numbers that are less than 5, and y is all the numbers that are greater than 5. So what's the relationship between x and y? Well, the relationship is that any number that you pick for x, it's always going to be less than any number you pick for y. No, 22, 24, 24. X is less than 10, so let me graph that. So let's understand what those numbers are. If x is less than 10, we're talking about these numbers. Here's 10. It's not equal to 10, so we can't talk about 10, but any number, so x is representing every single number less than 10. 9.9, 9.8, 7, 2, negative a million. All these numbers to the left. So these are all the x's. And then y and 5, and then z is greater than 10. So let's understand what z represents. So here again, number line. Here's z. Not z. Here's 10. We're not talking about 10 because 10 is not part of the solution, but we're talking about any number that's greater than 10. So 10.1, 10.2, 11, 15, 20, a million. So z represents all these numbers that are greater than 10. X represents all these numbers that are less than 10. So now they're asking you for the relationship between x and z. So if you pick any x number and compare it to any z number, any number that z represents, which are greater than 10, what will be the relationship here? Well, x. Any x number that you pick will always be less than any z number that you pick. Is there more? I don't know. Oh, there is more. What was that? 24? Okay, 26. Whether determine whether the statement is always, sometimes, or never true. Oh, I love these questions. 6. If C is greater than D, then C plus A is greater than D plus A. So think about it. Here's C, which is greater than D, right? If you want to pick a value, I don't know, pick 8 greater than 3. That's right. That's a statement, right? One number is greater than the other. And then let's say you add a value. Let's say you add a to both sides. Well, remember when we talked about the properties, right? If you have an inequality and whatever you add here plus whatever this number is, as long as they're the same to both sides, right? As long as they're the same, you add. Will the inequality, the order of inequality stay the same? Yeah, it will stay the same. So it doesn't matter what this a is, right? Whatever you add to both sides, it's not going to change. So again, let me do an example here. So let's say 8 is greater than 3. You can add 50,000 to the left side, comma, plus 50,000 to the right side. And guess what? Well, when you add it, you're going to get 50,008. This one, you're going to get 50,003. Is the left side still greater than the right side? Yes, it is. So you can play around if you don't believe me. You know, add different values to both sides, as long as obviously the same value to both sides. And you'll notice that this relationship will always be true. The left side, no matter what you add to the left side, as long as it's the same, and you add to the right side, the left side will always be greater than the right side. Okay, so this one is always. 30, if x is greater than y and z is less than 0. Ooh, okay, so if x is greater than y and z is less than 0, what happens when you divide both sides by z? Well, let's think numerically. So let me pick two easy numbers. 8 is greater than 4. Okay. Now z, this says that z is less than 0. So let's pick a number less than 0, right? Because it says here, divide both sides by z. And the z represents all the numbers that are less than 0. Let's pick an easy one. Let's divide both sides, and let's say z equals -2. So let's divide both sides by -2. Now, if we divide both sides by -2, 8 divided by -2 is -4. 4 divided by 2 is -2. So will that stay true? So is it true? Is -4 greater than -2? No, it's not. So if there's a relationship where you have a number on the left that is greater than the number on the right, and you divide both sides by a negative number, okay, the order of inequality will not stay true. So this will never happen. So this is a never. So 30 would be a never. And again, play with numbers, substitute x and y. I don't know. I chose 8 and 4. So if you want to pick -10 is greater than -20. So again, let's pick negative numbers, right? So -10 is greater than -20, and again, z is less than 0, which means z has to be a number less a negative number. So let's pick a negative number. Let's divide this by -5 and this by -5. Let's see if that inequality stays true. Negative divided by negative is a positive. 10 divided by 5 is 2. And then -20 divided by -5 is 4. Is this true? Is 2 greater than 4? No. So no matter what you do over here, right, divided by a negative number, the inequality will not remain true because you need to reverse it. 32. A times B is less than 0. Then A is less than 0 and B is less than 0. So let's think about that. Let me make this a little bit bigger. They're saying that if you take a value for A, right, a number represented by A that we don't know, multiplied by a number represented by B that I don't know, it's going to be 0, less than 0. So basically it's going to be a negative number, right? Does that mean that A is less than 0 and B is less than 0? Is that true? Well, let's pick a number that is for A that's less than 0. Let's say A, so it has to be less than 0. So let's say A is, I don't know, -2. So they're also saying that B is a number less than 0. So let's pick B is -8. Now if I change this to -2, change this to -8, will this be a true inequality? -8 times -2 times -8 is actually negative times a negative, which is a positive. It would be less, is 16 less than 0? So under this condition, right, A times B has to be less than 0. A will always be negative, and knowing that A is always negative and B is negative, will this happen? Is there will that ever happen? No. So this is a never true. Never true. Because you can't get two negative numbers to multiply and equal a number that's less than 0, right? Remember, negative times a negative is a positive, right? So a positive number is greater than 0, not less than 0. So this is never. Yeah, that's it. We only talked about even numbers. Okay, so relatively simple. Okay, and again, if you had these variables and there's no value, so give it some value, right? And then play around with it. All right.